Now we have discussed about the engineering thermodynamics subject. Topic is steady and unsteady flow process. Myself, I am Jav Singh, Assistant Professor, Rohini College of Engineering and Mechanical Department. Now we have discussed about the constant volume process. For constant volume process, work can be done by some method of the liquid. There cannot be any work external force has been moved through distance. Hence, we must zero or negative for the constant volume unless otherwise state work done is taken as zero. Thus, the energy equation for the constant volume process usually written as Q is equal to U2 minus U1. That is the formula Q is equal to U2 minus U1. If in addition to work being zero, it is the heat is transferred by virtue of any infinitely temperature difference, the process is reversible and equation can be written in differential form as dq equal to du. That is dq equal to du. Next, constant pressure process. A closed system undergoing at constant pressure process is shown in figure. You can show this the figure. The fluid is enclosed in a cylinder by a piston on which resists a constant weight. If heat is supplied, the fluid expands and work is being done by the system in overcoming the constant force. If the heat is extracted, the fluid constants and work is done on the system by the constant forces. In the general case, Q minus W is equal to U2 minus U1. Already we have discussed the formula Q minus W equal to U2 minus U1. So you can see the diagram, the work will be done by W will be mentioned. If no paddle work is done by the system and the process is reversible, dq minus p dv is equal to du. Since p is constant, this can be integrated to give q minus p close the bracket v2 minus v1 equal to u2 minus u1. Thus the energy equation become dq minus dpp equal to du or dq equal to du plus pv equal to dh. That is the equation. Using this derive the properties. The energy equation for reversible constant pressure process becomes, once again, the reversible constant pressure process becomes Q is equal to H2 minus H1. Next we go see about the polytropic process. The constant volume and constant pressure process can be regressed as limiting cases of a more general type of process in which both volume and pressure change in a certain specified way. In many real processes, it is wondered that state during expansions or compressions can be expressed as PV power n equal to constant. PV power n equal to constant. Where n is a constant. Where n is a constant called the index of expansion. Called the index of expansion or compression, and P and V are the average value of pressure and specific volume for the system. This is called polytropic process. This is called polytropic process. When n is equal to 0, the relation reduces to P is equal to constant, and when n is equal to constant, it is reduced to V is equal to constant. That is the chart for the isobaric process. P is equal to constant, n is equal to 0. Isothermal process, T temperature T is equal to constant, n is equal to 1. Isometric process, V is equal to constant, n is equal to infinity. Isentropic process, S equal to constant, n is equal to K. So you can see this, the chart will be mentioned, the x-axis will be mentioned volume, then y-axis will be mentioned by the pressure. So all the values are considered by the chart. So n equal to plus or minus infinity and n is equal to minus 2, n is equal to minus 1. That is the every process will be mentioned for the index, constant index values. That will be changed on the process. Next we have discuss the reversible adiabatic process. That is called, another name is isentropic process. The term the adiabatic is used to describe the any process during which heat is prevented from the crossing the boundary of system. That is, an adiabatic process is one undergo by a system which is thermically which is thermally insulated from form of its surrounding. For adiabatic non-flow process, the energy equation reduces to W is equal to U2 minus U1. PV is equal to constant. Then isothermal process, when a quantities of heat and work are also proportionality during a process such that the temperature of fluid remaining constant. The process is said to be isothermal since temperature gradient are actually by definitions of irreversibility of isothermal processes inbuilt. Next, we have discussed about simple problem. Listen, a institution rigid tank of 1.5 meter cube of air with a pressure of 6 bar and 100 degrees Celsius discharged into the atmosphere, which it is 1 bar through a discharge pipe. Still, it is pressure becomes 1 bar. First, calculate the velocity of air in the discharge pipe. Second one, evaluate the work can be obtained from the frictionless turbine using the kinetic energy of that air. Given data, so first of all, VA is equal to VF is equal to V, that is 1.5 meter cube. PA is equal to 6 bar. We have converted to kilobars, 600 kilopascal. Then next, PF is equal to 1 bar, that is also 100 kilopascal. Then R is equal to 1.4. Then R is equal to 0.287 kilojoule per kg Kelvin. CV is equal to 0.718 kilojoule per kg Kelvin. For air, Cp is equal to 1.005 kilojoule per kg Kelvin. So the fine value already we have discussed the fine value. Solution. It is the tank discharge air. So we have write the formula as insulated Q is equal to 0. So they write the formula say TF divided by TA is equal to PF divided by PI power gamma minus 1 divided by 4. Gamma minus 1 divided by gamma. So TF is equal to, we have calculated the value of 223.6 K. Next, we write the formula PI divided by RTI is equal to 8.407 kg. So that is also the value of the next level of formula. PF divided by RTF is equal to 6.069 kg. That is the value. So next formula, we got write the next formula M of UF minus MI plus M HD plus CD square divided by 2000 equal to 0 kilojoule per kg. The formula for the coefficient of coefficients CD is equal to root of 2000 M of UF minus MI divided by M minus HD. The C2 value is equal to 410.9 meter per second. Next, the turbine work formula is half into M C2 square is equal to the values of 51,290 joule. That is the answer. The turbine work. Thank you.